Bonjour. This is the second video for this chapter. Utiliser le calcul littéral pour résoudre ou démontrer. In the first video, we looked at this part of the chapter, page 28. We looked at this part of the chapter, Identité remarquable. Today we will do this second part of the not the second part, this third part, inequation du premier degré à une inconnue. This is resolution algebraique d'une équation du premier degré. What does premier degré mean? In English, it's first degree. It means that if you have an equation like this here, 5x minus 1 is equal to x minus 9. It's called first degree because it is only x to the power 1 here. No x square, no x cube. So it's called a first degree equation. Second degree equation would be an equation that has, for example, this, if it was 9x squared plus 24x plus 16 is equal to 0, that would be a second degree equation because it has x squared in it. Here all of this is first degree equation. We will not cover this because this is what you did in chapter 7 of Transmat 4, Modéliser une situation. Remember that? You even watched the video very recently. Okay. So, this is the topic we will cover. It's quite dense. That means there's a lot of material to cover. And as always, I will give you some in-video problems to do. Okay. So, let's start. The first thing is, let's just recap some of the basics which were covered in chapter 7 of the previous book. One is égalité. Égalité or equality in French are when two mathematical expressions are linked by the equal sign. So this is in égalité. 2 plus 3 is equal to, wonderful, 2 plus 3 is equal to 1 plus 4. Excuse me there. Little arithmetic mistake. And so what is an equation? An equation or equation is an égalité avec un ou plusieurs inconnus. So that means that if you take two mathematical expressions linked by the equal sign, and if one or both of them has one unknown, then that égalité is called an equation. Example is 2x plus 7 est égal à 3x plus 16. This is both an égalité as well as an equation because these are two mathematical expressions, 2x plus 7 and 3x plus 16, which are linked by an equal sign. They are equal and they include an inconnu, which is the literal. This is the literal value. This is represented by the letter x. Okay. In an equation, we can add the same number to both sides of an equation. So if I take this equation, I add 20 to this side and 20 to that side, the equation will still be valid. And the value of x, the solution, here the solution of course is the one value of x that will satisfy this égalité. That means if I find a value of x and put it in here, the value that we get from the membre gauche, left member, will equal to the value we get when we plug in the same value of x into the membre droite, or right member. Okay. I'm talking rather fast here because these are things you already know. We can add the same number to both sides of an equation without changing the equation. We can subtract the same number from both sides of an equation without changing the equation. We can multiply both sides of an equation by the same number. When I'm saying number, you can even multiply it by the same mathematical expression. It doesn't have to be a number. You could multiply this side by x and this side by x, and still the equation would remain unchanged. So multiply both sides of an equation by the same number, non-zero. You have to remember that when you multiply, you have to multiply by a non-zero number. If this rule is valid only if you multiply by non-zero numbers. And similarly, divide both sides of an equation by the same number. You can divide both sides of the equation by the same number, as long as that number is again not 0. anyway, division by 0 makes no sense. Okay, so now we come to an example of how we did this. So 2x plus 7 est égal à 3x plus 16. How to solve this equation? We subtract 3x from both sides. I've circled it in red. We are subtracting 3x from both sides. So here I'll get 2x minus 3x minus x plus 7. Here I'll get 3x plus 16 minus 3x. I'll get only 16. Basically what we are doing is we are moving this 3x to the other side and changing the sign and removing it from here. Similarly, so we end up with minus x plus 7 is equal to 16. Now we move the 7 to this side. How do we do that? We subtract 7 from both sides. So we subtract 7 here, we subtract 7 here, we get minus x is equal to 16 minus 7, which is equal to 9. So minus x is equal to 9. We multiply both sides by minus 1. We are allowed to do that because minus 1 is not 0. And we'll get minus x multiplied by minus 1 is x. 9 multiplied by minus 1 is minus 9. And this is the solution of the equation. X is equal to minus 9. If you plug it into the membre gauche and calculate, and you plug it into the membre droite and calculate independently, you will find that both numbers are come out to the same value, which means that x is equal to minus 9 is indeed the solution of this equation. Okay, so now this is a quick recap of this part of the book. Now we come to the actual substance of this video, which is inequation du premier degré à un inconnu. Inequation du premier degré avec un inconnu. So, an example of an equation and of an inequation is basically same as an equation, but instead of the equal sign, you have an unequal sign, which is either greater than or smaller than or greater than or equal to or smaller than or equal to. The aim of solving an equation like this is to come to x is greater than something or x is smaller than something. So you have to have just x on the left side and you have a term on the right side which is just a number which doesn't have x. So in a way, the way you solve this, you can also solve this. Remember that I've shown here greater than and less than, but it could be greater than or equal to or less than or equal to also. You know those signs. So you draw an extra line below the lower slanted line to indicate that it could be greater than or equal to or less than or equal to. X est supérieur à quelque chose, x est inférieur à quelque chose, x est supérieur ou égal à quelque chose, x est inférieur ou égal à quelque chose. That this is this one and this is this one. This is superior ou égal à, this is inferior ou égal à. Okay, so let's turn the page. Rules for adding, subtracting, multiplying, dividing both sides of an equation are same as for an equation. So you can multiply by both sides by the same number, you can divide both sides by the same number, you can add the same number to both sides, you can subtract the same number from both sides. But, and it's a big but, there is an exception, except if we multiply, divide both sides of an inequation by a negative term. The sign, the greater than or less than sign changes. This will become this. This will become this. This will become this. Greater than will become lesser than. Smaller than will become greater than. Greater than or equal to will become smaller than or equal to. And smaller than or equal to will become greater than or equal to. So let's take a quick example of this. Is fairly simple once we see how it is. So I say 7 is greater than 3. This is true. Obviously it's true. 7 is greater than 3. If I multiply both sides by minus 1, what will happen? I'll get minus 7 is greater than minus 3. But is this correct? No, minus 7 is actually smaller than minus 3. So because we have multiplied both sides by a negative number, we have to flip this sign. You have to reverse this sign. So you'll get minus 7 is smaller than minus 3. So even though 7 is greater than 3, here minus 7 is smaller than minus 3. Because you multiply both sides by a negative number, in this case minus 1, you have to flip the sign. Okay, so we will take an example and we will solve it. In this case, there is no flipping of the sign, you will see. So we have 2x plus 7 est plus grand que est supérieur à 120 moins 6x. So I take 6x on this side. How do I do that? I add 6x to both sides. So here it will become 0, here it will come there. 2x plus 7 plus 6x est plus grand est supérieur à 120. We get 8x plus 7 est supérieur à 120. This 7 now we will take to the other side by subtracting 7 from both sides. I will get 8x est supérieur à 120 moins 7. Donc 8x est supérieur à 113. Donc x est supérieur à 113 sur 8 divisé par 8. How did I come from there to there? I divided both sides by 8 and I got this. Now if I put this into my calculator, I get x est supérieur à 14,125. Now don't take a shortcut and write here 14.125. That is not the way to do it. You have to write it in a separate line. Don't mix the equal sign and greater than or smaller than signs in the same line. Okay, so now we can actually see the verification of this, and I'm writing here again on the side. This is not something I want you to do. I'm doing it only because I want to see this at the same time, and it's the end of the page. So here let's take x est égal à 15. So membre gauche becomes 2 fois 15, 2 fois x, 2 fois 15 plus 7 est égal à 37. Membre gauche est 120 moins 6 fois x, 6 fois 15, 6 fois 15 is 90, 120 minus 90 gives 30. So membre gauche est plus grand que membre droit. 30 is greater than 37. So this, if we take x is equal to 15, this equation is satisfied. So we can see that here this is sort of correct. Let's take a smaller value. Let's take x is equal to 14. So membre gauche becomes 2 into 14. 2 into 14 plus 7, that will give us 35. 2 into 14 is 28. 28 plus 7 gives us 35. Okay. Membre droite, 120 minus 6x, 120 minus 6 into 14. If you do this, you will get 36. And you see membre gauche is no longer greater than membre droite, because 35 is not bigger than 36. So if we write this, this is wrong. So we can see that this, in a way, that what we have solved is correct. If x is greater than 14.125, this value is greater than this. This term is greater than this term. If you take x is equal to 14.125, you will find that this is equal to this, and that doesn't satisfy this sign. If it had been here, if there had been another line here like that to indicate that superior ou égal à, then you would have the same line here. But in this case, 14.125 is not a solution of this inequation. Any number greater than 14.125 is indeed a solution to this equation. I should now just remove that little line that I drew. Okay, so let's take another example, and this example we will actually see the sign changing. I've chosen an example where the sign flips. Okay, so this is the inequation 6x minus 12 is smaller than 12x minus 25. Please solve this. So how do we do this? First thing is we move the 12x to the left. So this will become 12 plus 12x becomes minus 12x here. You know what we are doing, we are subtracting minus 12x from both sides. That is allowed. Then here minus 12, we want to move to this side, so we add plus 12 to both sides. This side will cancel out, it will become 0. Here we get plus 12. So you will get here minus 6x is smaller than minus 13. Now I want to get rid of the minus, so both sides I multiply by minus 1. But when I multiply by a negative number, the sign has to flip. So then that's what is happening. I multiplied by minus 1. 6x is greater than 13, and here the sign has changed because I multiply both sides by a negative number. Or if I divided both sides by minus 1, I would get the same thing. Either multiply by minus 1 or divide by minus 1, it's the same thing, and again in that case also the sign changes. So x has to, now I divide both sides by 6. 6 is a positive number, the sign remains unchanged. X divided by x is greater than 13 divided by 6. So I get, when I plug that into my calculator, I get x is greater than 2.16666 repeater 6. Okay, so now let's verify this by two values. One we'll take as 2 and one we'll take as 3. First let's take 3. 3 should satisfy this inequation. Si x est égal à 3, membre gauche est égal à 6x moins 12. 6 fois 3 moins 12, this is 18 minus 12, gives us 6. I'm talking a little fast, slow down the video if you like. Membre droite is 12x moins 25, 12 fois 3, 12x moins 25, 12 fois 3, 36, moins 25, gives 11. So 6 on the left is 6, 6 is smaller than 11, donc mg plus petit que md. So this equation is satisfied for x is equal to 3. This inequation is satisfied for x is equal to 3. You can see x is actually, if it is greater than 3, this is a solution. Similarly, now we take a value that is smaller than 2.16. We'll take c x est égal à 2. Membre gauche is 6x minus 12. 6x minus 12. That is 6 into 2 minus 12. 12 minus 12 gives us 0. Membre droite is 12x minus 25. 12x minus 25. So I get 12 into 2 minus 25. This is 24. 24 minus 25 is minus 1. So here we see 0 is actually greater than minus 1. So therefore, membre gauche is smaller than membre droite, et plus petit que membre droite. So this is not a solution to this inequation, which is correct because we have found out that it has to be greater than 2.166. If we took 2.17, you would see, you can plug it in and this inequation will be satisfied. You take 2.15 and you plug it in, you will see that this inequation is not satisfied. Okay, so now some in-video problems, 4 of them are résoudre this, and an equation 2x plus 1 is equal to 6x plus 15. So these 4 you have to solve. Okay, so I was going to end this video here, and then I realized that on this, in this little part, they have one little corner here where they use the number line to indicate the solution. Now the thing is, here if you look closely, they use colors red and black, and it's not very clear. So what we will do is we will do mark out the solution. This solution they have found x is smaller than minus 3. We will mark it out using a single color. So that is what I'll do to conclude this video. So inequation, représentation sur la droite graduée. So suppose we find this is our solution. X is greater than 5. So first we draw the droite graduée. 1, 2, 3, 4, 5, 6, 7 this side, negative numbers that side. and x has to be greater than 5. So these numbers I have hashed out in red, which means that these are not the solution. Any number which is not hashed out is the solution. So 6 is a solution, 7 is a solution, 8 is a solution, 10 million is a solution, 55 is a solution, 5.1 is a solution, because these are not hatched out. Yeah, that's the correct word. Okay, so, but see something interesting, that on 5 there is a curved line here. Is 5 a solution? No. X has to be greater than 5. This is not greater than or equal to sign, it is a greater than sign. Superior a. Pas superior u egal a. So this curved thing, it shows that number 5 itself belongs to this side. So that means it belongs to the non-solution side, whereas all the numbers greater than 5 belong to the solution side. But suppose what happens is, if the solution we had found was x is greater than or equal to 5, then the number line would be drawn like this. Again you have the same hatching here, but you will see that the curve is different, because it signifies that number 5 now belongs to this side, and this side is the solution. X has to be greater than or equal to 5. So 5 is a solution, 6 is a solution, 7 is a solution, 8 is a solution. Here 5 was not a solution. Let's take another example. X has to be smaller than -1. So in this case, all numbers smaller than -1 are the solution, all numbers greater than -1 are not the solution, and also -1 itself is not a solution, because it has to be less than -1, not less than or equal to -1. That's why the curved line goes like this, to indicate that the -1 itself value, -1 value belongs to this side of the number line. Okay, and if we took, so this is the thing. Now I would want you to draw 4 separate droite gradués. Don't mark them or try to mark them all on one thing. For these 4 values, x is greater than -2, x is smaller than 2, x is smaller or equal to -2, x is greater than or equal to 4. So draw these. You can draw them again, freehand like I have done, but make sure that there is no ambiguity. I can clearly make out what you have done. Okay, so this is where I stop, 23 minutes into the video. Watch it again if you like. It is a little bit, it's an introduction for inequations. We always knew equations, but what does it mean to solve an equation, to solve an inequation? Solving an inequation is to find the value of the unknown that satisfies that inequation. And they can be, because it is an inequation, the values can be infinite in number, like here. If we find out that x has to be greater than 2.16, then there are infinite numbers greater than 2.16, but also an infinite numbers below 2.16 which are not the solution. Okay, so it means a little bit of thinking, but you should get the idea. And one final point, here there is the final topic in this chapter is designation des nombres. This you read yourself and understand. If you don't understand, you ask me. This is so simple that I don't even want to waste my breath talking about it. Okay, so I'll stop here, and you please do solve these three inequations, solve this equation, and draw 4 number lines. In English, droite gradient is called number lines for these 4 cases. Okay, I stop here.